Okay, so let's say we have a inequality. Five x plus 2 greater than 6. Now, how do we solve this inequality? Well, want to isolate x on this side and so forth. So we do 5x plus 2 minus 2 is greater than 6 minus 2, which means that 5x would then be greater than 4. 6 minus 2 is 4. Then we divide both sides by 5 to get x greater than 4/5. And of course, then we could graph this. We have 0 here, and let's say 1 here, and then we have other numbers out there. 4/5 is somewhat less than 1. In other words, if we divide the interval from 0 to 1 into 5 equal parts, then 4 of them give us 4/5. So right here, let's say is x equals 4/5. And the graph of this solution would not contain 4/5 because this is greater than. If it was greater than or equal, it would contain the point x equals 4/5, but it isn't. So we put an open dot at 4/5, and there's our solution. Now, by contrast, without going into all the details, if we have negative 5x plus 2 greater than 6, well, we subtract 2 from both sides, we get negative 5x is greater than 4. And then we have to divide both sides by 5. And when we divide both sides by a negative, we have to reverse the inequality. And we would get x less than negative 4/5. I'm not going to graph that, but this is just to illustrate what happens if you have a negative. So something we always have to be aware of. Okay. Now the inequality absolute value 2x less than 7, less than 7. Any inequality, well, the inequality is so as long as the absolute value of this quantity is less than 7, and that's going to occur as long as two x plus 7 is less than 7, and two x plus 7 is greater than negative 7. Both of these have to be true. Okay, so let's say it's just all 2x plus 7 less than 7. Well, we've just seen how to solve an inequality, so I'm not going to go through the steps of solving this inequality. I'm just going to put an ellipsis, 3 dots down here, and I'm going to get x less than 0. Okay. Now, just to kind of check that out before we go on, if x was 0, we'd have 2 times 0 plus 7, we'd have 7 less than 7. Okay, well, 7 isn't less than 7, it's equal to 7, but if x is then less than 0, 2x will be some negative number, that'll make this less than 7, and that's probably going to work. The only problem is, if x was like negative 5, or let's say negative 10, if x was negative 10, 2 times negative 10 is negative 20. Negative 20 plus 7 is negative 13 and the absolute value of 13, negative 13 is 13, and that isn't less than 7. So if you go too far into negative numbers, this isn't going to work. If x is a big negative number, you're going to get a big result here. It's not going to be less than 7. That's why this breaks into this and this. Okay, so x has to be less than 0, and it has to be, well, 2x plus 7 can't be less than negative 7. It's got to be greater than negative 7. So that in this case, x has to be greater than negative 7. If we solve this inequality, we would subtract 7 from both sides, we get negative 14 here. And then we divide that by 2, we get x greater than negative 7. Now, if we try to graph that, okay, here's the origin, x equals 0. X has to be less than 0. And that includes all values of x, like so. So here is x less than 0. But also, x has to be greater than negative 7. So let's just say that x equals negative 7 here. And here is an arrow representing x greater than negative 7. X less than 0 and x greater than negative 7 means that it has to be both on this line, on this arrow, and on this arrow. And the only numbers that are on both arrows are the numbers between negative 7 and 0. So this is negative 7 less than x less than 7. Now, this is a review. I'm not going to explain any more than that. But we need to try to understand this. By contrast, if it had been absolute value 2x plus 7 greater than 7. Yeah, well recorded. Okay. Then this would have broken into two inequalities, 2x plus 7 greater than 7. And my 7s are looking a whole lot like greater than signs. Let me rewrite that. Okay, so we have 2x plus 7 greater than 7, or 2x plus 7 less than negative 7. So we would have then x greater than 7, or x less than negative 7. And if we were to graph that, if this is x equals 0, and this is negative 7, and 7 would be out here, and x greater than 7 would be this interval to the right of 7. X less than negative 7 would be this interval to the left of negative 7. And the solution would be any number in this part or in this part. It can't be in both parts. And there's a contrast here. We have up here, we have an and. This means x has to be both less than 0 and greater than negative 7. And there are plenty of numbers that are less than 0 and greater than negative 7. Down here, there are no numbers in here that are also in here. So it's got to be in here or in here. So that logic is important and worth understanding. Okay, now I'm going faster because you got a lot of stuff to do. We're not going to stop and work on things today. We're going to get this review down. Well, you know, let me get my screen here just a little bit. I can see what I'm doing. Okay. Okay, now we have a problem we want to solve for x. If it's -8 multiplied by 6x minus 8 minus 6 equals I'm going to do it like this: 6 times -8 minus 8 minus 8. There's a bunch of 8s in here. It should be minus 8x. But that's just coincidence in the way the randomizer made up this problem. Okay, so it doesn't matter. We're just going to deal with this. The fact that we've got all these 8s doesn't really matter. We multiply things out. We use a distributive law here. We get -48x plus 64 minus 6. 6 times -8 is, except let's make that -6 times -8. -6 times -8 is 48. So we have here 48x plus 48 minus 8. Okay. Now we want to simplify things. We'll add the 64 and the -6, which gives us 56, 58. We add the 48 and -8, we get 40. Then we have our 48x here and our -48x here. Then we want to get our x's on this side, so there are several things that we could actually do here. Several ways we could proceed. But what I'm going to do is I'm just going to subtract 48x to both sides. And that'll get rid of this 48x, and I'll just have 40 on this side. And -48x and -48x is -96x. I still have the 58. Of course, I want to get the 58 on this side, so we subtract 58 from this side and subtract 58 from this side. We get -96 equals -96x equals -18. If we then divide both sides by -96, we get our solution. We get x equals, now 18 over 96. Having trouble writing 8s. Too bad this problem generated so many 8s. A combination of the chalk and doing my hand work, it's been working. Okay, so we get 18 over 96. And of course, that reduces to 3 over, actually, I divide that by 9. No. Divide by 6. No, I'm divided by 6, not 8. Never mind. Okay, that's going to be 3 over 16. Okay, so our final solution is x equals 3 over 16. And the steps are very straightforward, just as there are a lot of them, so we got to be careful that we do the steps in reasonable order and do them carefully. Okay, Yeah, we got a problem involving percents here. Price is reduced by 30%. Original price of $200. What is the reduced price? Well, it's reduced by 30%. That's 30% of the original price. We take 30% of 200, which is 0.30 times 200, which is fixed. Okay. Well, the new price is $200 minus $60 equals $140. Another way reducing by 30% leaves 70%. $70% of $200 is $140. Now it's the same solution. There's just two different ways of looking at it. One is you go ahead and compute 30% of 200, subtract that from 200, and you get $140. The other way is you take 30% away from 100%, which is what you started with, and you leave 70%, take 70% of $200, you still get $140. So it's worth making sure we understand that idea. Now there's another. Thing we can do. A related problem. It did not necessarily occur on the test. Might be after 30% reduction, price is, let's say, $400. Now this is a different problem than this, so I'm going to use different numbers. And I probably don't want to use a 30% reduction. I'm going to use a 20% reduction. Okay, after 20% reduction, the price is $400. What was the original price? Well, let's let X equal the original price. after 20% reduction, your price is X minus 20% of X, and 20% of X is 0.20F. And that equals 0.80X. 0.80X is our price after reduction, which is $400. So that's, well, we solve this. Take our 0.80X divided by 0.80. That equals our $400 divided by 0.80, which equals $500. X is $500. We said originally that X is the original price. And that's what we try to find. There's our solution. Okay, well, let's see. Next problem I see. Absolute value of -5 minus 10 equals what? Well, you work inside the absolute value signs. -5 minus 10 is -15. And the absolute value of -15 is 15. That's it.
And that, but it's something, no, okay, you think it's
Okay,
bad?
another problem.
Go to the second. Yes, baby, in the detail.
Eight times 6x minus 3 equals -3. We use the distributive law, multiply through here, we get 48x minus 24 equals -3. And then we're going to add 24 to both sides because we want to isolate x on the left-hand side. We get 48x minus 24 plus 24 equals -3 plus 24. I just barely got that 24 in there. I think that should be visible, at least on the screen. And we get 48x equals 21. So we divide 48x by 48. And then we have to, of course, divide the other side by 48, giving us x equals 21 over 48, which is 7/16. If I reduce that correctly, we divide 21 by 3, we get 7. We divide 48 by 3, we get 16. So pretty straightforward problem. Make sure we reduce correctly. And there's something else I was going to say about this. Yeah, the way I'm writing these out is, I think, the third way to write them out. Any ways that people add 24 to both sides. That's often done incorrectly, so I don't like to encourage it. But if you're doing it correctly, I'm fine with it. But I'm not going to encourage it by actually doing it. Okay. I just see way too many mistakes. People do that. For another little board right there. Okay. And I have to these over just a little bit. There we are. Okay. Now, let's take a fraction 5/8 divided by 20/3. Now, it's a complex fraction, a fraction divided by a fraction. Okay? Numerator is a fraction, denominator is a fraction. Now, this means this divided by this. So we just use the fact that the fraction line means division, and we say, okay, that's 5/8 divided by 20/3. And then we use the rule that we should always know. Division by fraction is multiplication by its reciprocal. So this is 5 times 3, which is 15, over 8 times 20, which is 160. Now, 15 and 160 are both divisible by 5. When we divide 15 by 5, we get 3. We divide 160 by 5, you get 32. So there it is. Now, if you're ever doing one of these and you want to check, go ahead and evaluate this fraction on your calculator, evaluate this fraction on your calculator. Now, you might use just the fraction utility and just divide this directly, and it'll tell you 3/32. If you don't have that utility, if you can't do fractions on your calculator, you can still calculate this as a decimal number, calculate this as a decimal number, and see that they agree. And I'm not doing checks on these problems, which means, of course, I might have made a mistake. You want to go through and check me just so you get used to checking problems. Okay? Because checking problems is maybe the most important step in solving problems and learning from what you're doing. You get immediate feedback on whether you're right or not. Of course, it could be your check is wrong, but you still have to resolve that. You learn a lot by doing that. You want the area and circumference of a circle of radius 6. Okay. Now, the area of a circle is pi r squared. Thing I would remember about circles is that the circumference is pi times the diameter, meaning pi is just the ratio of the circumference to the diameter. Pi is close to 3, so the circumference is about 3 times the diameter. If you draw a circle, not very well drawn, here's your diameter. If I try to wrap that diameter around the circle, it's going to go around about 3 times. Makes a certain amount of sense. You can think about that. It's actually approximately 3.1415926. And then I don't remember what the rest of the numbers are. 3.14 is sufficient for this course. And if you need more, your calculator is going to have, about 10 or 12 significant figures, if not more. Now, why is that 2 pi times the radius? It's because the radius is half the diameter. You have to have the radius twice to get the diameter. So pi times the diameter is the same as 2 pi times the radius, because the diameter is 2 times the radius. Anyway, you have to know these things. Okay. And we're not gonna give you a formula sheet that tells you these basic geometric things. Okay. What you then do, you try to find the area and circumference. If the radius is 6, well, if the radius is 6, you put 6 in here. So area is pi times 6 squared. 6 squared is 36, so it's 36 pi. So do that maybe. There's your area. Pi r squared, pi times 6 squared, 36 pi. In the circumference. Now, okay, the radius is 6. Radius is the distance from the center out to the arc of the circle, that's 6. This is from the center. That means this diameter is 12. If you multiply diameter by pi, you get 12 pi. Or if you do 2 pi times the radius, you get 12 pi. I'll use 2 pi r for the circumference. And that's going to be 2 pi times 6, which is 12 pi. And that's just pi times the diameter. Okay. Really easy to confuse 2 pi r with pi r squared. But you should have the idea that when you get an area, you got to multiply like length times width, or the area of a square would be the length of a side times the length of a side. You'd be squaring things. Okay, you're gonna have to multiply two things together, and r squared does that. Okay, two dimensions together. So you got to multiply r times r effectively. Down here, you only got a single r, and it's not multiplied by any other dimension. And that's not going to give you an area. That's going to give you a length, the length of you would have if you unwrapped the circumference, unwrap it out into a line. Cut this here, stretch it out, you would have a line equal to the circumference. Okay, well, might or might not pick up on what I said there, but be good if you would. Okay. Now we got something to solve for x. It wraps around to the other side of the paper. And this was really easy. Six x plus 4 equals 0. Subtract 4 from both sides. You get 6x equals -4. Divide both sides by 6. You get x equals -4/6 equals -2/3. And that's with n easy. Okay. Solve absolute value of x equals 8. Majority of the time I see people just write x equals 8. Say that's it. Well, that is a solution. If x is 8, then the absolute value of x equals 8. But you don't solve an equation by finding just one solution. You find all solutions. A lot of times there is just one solution. For this equation, there's just one solution. But for this equation, the absolute value of -8 is also 8. So what we do is we split an absolute value equation into two equations, and you get two solutions. And you can check this. Plug in -8, the absolute value of -8 is 8, that makes it true. Plug in 8, the absolute value of 8, of course, is 8. So you have two solutions. If you have absolute value of x minus 7 equals, why not 8? We're seeing a lot of 8s in this thing. Okay, what do? Whatever's an absolute value sign has to either equal 8 or negative 8. So you say x minus 7 equals negative 8, or I could put the or here, or x minus 7 equals 8. Solving that, we get x equals negative 1, or x equals 15. We can check that. Plug in negative 1, you get negative 1 minus 7. Negative 1 minus 7 is negative 8, and the absolute value of negative 8 is 8, so x equals negative 1 works. If x is 15, you get 15 minus 7, which is 8. And of course, the absolute value of 8 is just 8, so 15 works. So we check and we verify. Okay. And then we have a calculation with a fraction that I'm tempted to squeeze in the space I have here. But I'm going to just come over here and clutter up a little bit more of this board. Okay. So what we have is m7 minus negative 3 over 5. What's that equal? Well, that's the same as 10/7 plus 3 over 5. And now we're going to use a common denominator. Okay, well, 7 and 5 don't have any common factors. There's nothing, at first place, they're both prime numbers. So there's no other number that divides either one of them. So the common denominator is going to be 35. So we get 10 over 7. We multiply that by 5 over 5, which is just like multiplying by 1, because 5 over 5 is 1. It doesn't change the value of this thing. And you see how the denominator is going to end up being 35. And then with 3/5, we multiply by 7 over 7. The denominator is going to again be 5 times 7 or 35. So now we have 50 over 35 plus 21 over 35. Now, if you don't believe that this fraction has the same value as this one, and this one has the same value as this one, go ahead and just plug it into your calculator. Plug in 50 over 35, get a decimal equivalent. Get a decimal equivalent to 10 over 7. It's going to be about 1.43 something. Okay. 3/5 is 0.6. 21 over 35 is 0.6. You can verify it that way or in any number of ways. The whole idea is we multiply both fractions by some number over itself. Okay, we multiply each fraction by some number over itself. Different numbers for different fractions. A number over itself is equal to 1, so we haven't changed the value. When we multiply something by 1, it retains its value. That's the whole principle behind this. Okay. Now we have the same denominator. So this is 50 plus 21 over 35, which equals 71 over 35. 71 is a prime number, so this won't reduce. Okay, now that is test 1, and test 1 is all over elementary algebra, which of course is a prerequisite for intermediate algebra. Now we find that a lot of people think they know elementary algebra better than they do, and we're not doing placement testing. I question the wisdom of that, but a lot of people end up in this course needing a lot of work on elementary algebra. We spend about a third of the semester on elementary algebra. Then we have to hustle and cover intermediate algebra. So if your elementary algebra is not up to it, what I'm going to say is, don't drop the course. The worst you're going to get out of this course is a U, and it's not going to affect your point average. Stick with it. If you've got to continue working on elementary algebra, go ahead. If you're into the intermediate algebra and doing okay, that's fine. We're going to have a midterm test. Unfortunately, it's going to be next week, which is after the drop date. Again, I don't advocate that anybody drop. You're in the course, stay in it, learn as much as you can if you're not on top of it. And most people aren't. And it's very possible that if you work hard, things come together and you end up doing quite well in the intermediate algebra. And then it won't matter if you didn't do particularly well in the elementary algebra. Now, you still, if you can do the intermediate algebra, that means you pull the elementary algebra together. And the way I'm going to grade is test one isn't going to count against you if you do okay on the intermediate parts of the rest of the course. So if you didn't do well on this, and only one person passed this, and I have to say that out of not a dozen people in these classes, okay? So if you didn't pass it, you've got a lot of company. But if you did pick up enough to give yourself a foundation for the intermediate algebra, then that's very good. Okay, now that's not a comprehensive review of the elementary algebra, but I'm not going to talk about elementary algebra anymore in this course. Because we have to concentrate on the intermediate algebra. We're going to use elementary algebra in developing the intermediate algebra, so you're going to see more of it. Now I want to do some intermediate algebra problems, because even though we're not going to be able to do the midterm, this goes back to, we had a series of technological glitches here that have set everything back, and we're going to be a week behind. He's going to do the midterm this week. It's going to have to be next week. What I'm going to do is I'm going to send out a sample midterm test for practice. And then I'm going to send out another one. And my instruction on this, you can follow the instruction or not, but in other words, you can fool yourself or not. But you take that test under test conditions, no notes. Don't use a calculator for anything but simple arithmetic, and send me a copy. Or if you're on campus here, take it in the testing center. Or just take it on your own and turn it into the testing center. It won't be official. You're not going to get a grade that counts, but you're going to get feedback on where you are and how you're doing in the course. I see a lot of people making high scores on their homework. Okay, saw that for the elementary algebra part. People made high scores and then made 12% on the first test. And that tells me that people are not using the homework in a way that enhances their learning, or that accomplishes the learning objectives. I've advised people that you should, if you're not in class here where I can see you, I've advised people that you should be writing your work out and sending me scans of your work so I can see what you're doing, so I can give you some help. If you make 100% on the homework, but then can't do the same thing on the test, you haven't learned enough from your homework. That's all there is to it. And if I can see what you're doing by seeing what you're writing, then I can give you help. Now, if you're in the class, that's what we do. You should also consider, working through the class videos if you find that helpful. Because if it's not working, something's not working, you might consider using the class videos. Okay, so I'm going to go on with some intermediate algebra problems.